Right, so chapter 11 is about area of figures, and that's why I believe you probably already know this. You have at some point studied area before. So this is really more of a review than something new. On the front of your packet is this formula sheet. I'm not going to go through proving all the formulas or why they are what they are. Perimeter means the lengths around the edges. So as a general idea for perimeter, we're just adding up the lengths around all of the edges. And then we have our various area formulas for different figures. Parallelogram might be something new. Again, in terms of perimeter, we're adding up around the sides. When we find the area of a parallelogram, we're taking the idea that if we would cut off that little triangle that's kind of divided there by the dotted line, if we would actually cut it off, we could tape it to the other side of this and it would become a rectangle. So the area of a parallelogram is really then the same as the area of a rectangle. But we need to make sure that we're doing the length times the height of it, not that slanty part. Just as in a rectangle, we would do like a base times a height. We need the actual height of it there. As we scroll on down, we come to the rhombus formula. Rhombus does not need to be memorized. The other ones on here do. So I know some of you like Quizlet, or there's another app that's called Study Blue, and I know all of these are on there because I put them all in there last year. Same type of thing as Quizlet, or just regular flashcards, or however it is that you learn things, these formulas need to be learned. And I don't do that to be mean. I actually used to not require these to be memorized. I gave a formula sheet when you took the test on this. The reason why I have changed is because I used to do that with the belief that ACT gave you a formula sheet when you take that, and they don't. So these are things that you actually could need to know on those. So to better prepare you for those tests, that's why I have you memorize these. Most of them you have seen before, and they will probably come back with just a little bit of effort. Some of them might be new to you, like trapezoid might be a new one to you and might need a little bit more study on that. But most of these, hopefully, you're pretty familiar with already. The back of that is volume, and that's chapter 12, and we'll hit that at the end of this week and next week. So then we just have some examples here, and we'll just kind of run through our examples. Area of a rectangle, you don't have to draw pictures for all your problems, but I'm kind of a picture person. I like pictures. So I have a rectangle with a base of 12 and a height of 5, and I'm asked to find the area. The area of a rectangle is length times width or base times height or whatever letters you like, but the area of a rectangle, we just multiply those two measurements together. So we would do 12 times 5, which gives 60. If units are given in a problem, you need to give units in your answer. So in this problem, if we are taking 12 centimeters and multiplying it by 5 centimeters, we get 60 what?
Centimeters squared.
Centimeters squared. Area is always a squared unit because centimeters times centimeters is centimeters squared. Just like x times x would be x squared. So if units are given in the problem, make sure that you give units in your answers. The second one, find the base of a rectangle with a height of 8, and we don't know that base. We can call it b, we can call it x, we can call it whatever we want. We do know that the area of this thing is 120. Well, if area is base times height or length times width or whatever letters we want to use there, then 120 is equal to 8 times x. So we can divide and find that x would be 15. There are units in this question, so x is 15 what? Meters. The area is meters squared, but a length or a width or a perimeter, something that we can measure with a ruler, is just the plane unit of meters or centimeters or feet or whatever it is. Question 3, find the height and area. So in this one, we were asked for two things. We need to make sure we find both of those things. Some of your homework questions will ask you to find more than one thing. So make sure you pay attention to your directions and do it all, otherwise you'll be getting half credits. Of a rectangle with a base of 16 and a perimeter of 42. Perimeter means add up around all the edges. So perimeter would be a 16 plus a height plus a 16 plus another height if we're going around this thing. Okay? Or if you look at the formula on the sheet, the formula sheet on the front, it says like 2 lengths plus 2 heights. It's the same thing. Okay? We're adding up around all the edges. We have 2 of the lengths and 2 of the heights. So when I add up those 16s together, I get 32 and 2 heights. Subtract out that 32. Gives 10 is 2 heights. So a height would be 5 unit centimeters. Sorry, the mouse is placed a little bit badly there, but I can't move it actually once we start writing. But this question asks for 2 things. It asks for height and area. So we need to make sure we complete this question and say area is the base times the height. 80 unit centimeters squared. Square units for area. For the shape in 4, we don't have a name for that shape, it's just a thing. But it's made up of a lot of rectangles. There are a lot of different ways that we could cut this figure and turn it into rectangles, and there isn't necessarily a better way and a worse way. I'm going to choose to make some horizontal cuts like this, so I get 3 rectangles. You could make vertical cuts, you could cut it into 5 pieces if you wanted. But I'm just going to make those 2 cuts, and so now I have rectangles. At the bottom of this, it kind of looks like a square, but it's actually not. What's the area of that little piece at the bottom? 10, because it has sides of 2 and 5. So multiply that together and get 10. What's the area of the top one?
35.
35. How do you figure?
Because top one is 5.
Yeah, so down at the bottom of this, we have a 5, and since this thing is standing all straight up and down, that 5 must translate to be the top as well. So it has a side of 7 and a side of 5, because that 5 at the very bottom of this would have to translate up to be the same.
So are we trusting our eyes on this one?
We know that it's made of all right angles. You would be told, yeah. Yes, I guess we're trusting our eyes in that sense. Yeah, we're believing it's made of all right angles.
Yes, we could trust.
Now for the middle figure here, careful trusting your eyes though in general, because this bottom one says that it's 2 times 5 and it clearly looks like a square, right? So don't trust your eyes in that sense, but we're going to believe that these are all right angles here. In this middle one, really, we do need to either be told that this thing is symmetrical, or we should have been given a 6 over here as well. But we are going to believe on symmetry on this one. The book will be more specific. You won't have to make as many assumptions in the problems on the book. So we've got 6 and 6, and that middle part is 5. So that whole thing is then 17 times the 5 gives 85. For that middle rectangle. So putting together those 3 rectangles then would give us the total area, 35, 85, and 10, give us 130.
What? The area?
For the area, yep. There's no units provided in this problem, so you don't need to give any units in your answer. You don't need to say like unit squared. You can. I won't mark you wrong for saying that if you just want to include units in all of your answers and just say units squared if there aren't specific ones given. But you only have to give units if units are given.
What's the 85 for?
The middle rectangle, the area. That whole middle rectangle has a length of 17 and a height of 5. So section 1 of chapter 11 talks just about rectangles. So when you go to do your homework tonight, you'll be doing homework from 11.1. This was 11.1, and that's why I felt like we could probably keep going on this, because rectangles hopefully are not anything new for you. So then we go on to now areas of triangles. We're not told that this is a special kind of a triangle. So we don't know if it's a right triangle or anything else, but we do know the base is 6, and the height, which is a straight up and down, is 4. Okay, base is 6 and height is 4. And when we talk about the height of a triangle, we're talking about its straight up and down height, not on a slant. Our area of a triangle formula is 1/2 of base times height. Base times height is a rectangle, and a triangle is half of that, because if we put together two triangles, we could make a rectangle, or even if they don't have right angles, we could at least make a parallelogram out of it, which is also a base times height. So then we end up with 1/2 of 6 times 4, which gives 12, and there is a unit here, so we need to make sure to include units in our answers. A parallelogram might be a new one for you. Sorry, was there a question on that? We have here a base of 4 and a height of 8. Again, the height is straight up and down. Anytime we use the word height, we're talking about a straight up and down height, not measured on a slant. The area of a parallelogram is base times height, just like a rectangle, making sure that we're using that straight up and down height, not a slant height. So our base here is 4, our height is 8, and we get 32 with a unit in the problem of centimeters, so centimeters squared. Okay, area of a parallelogram is just like a rectangle, base times height, just making sure we're using the straight up and down height and not the slanty height.
Yes.
The rhombus is the one that I said you do not need to worry about memorizing. The area of a rhombus, as given on the formula sheet, is 1/2 of diagonal 1 times diagonal 2. The reason why I don't have you memorize this one is because I don't anticipate you ever really needing this formula. I honestly don't know this formula other than like the week where we're studying this, and then I'm like, oh yeah, that's what it is, and then it goes away again until next year. So this isn't an area of concern as far as memorizing goes. But we'll have the formula in front of us then when you do your homework. 1/2 of the first diagonal is 10 and the second one is 5. And we get then 25 meters squared.
Not even that hard to memorize, so.
Yeah, that's true.
It's not, but you know, there's enough other stuff to memorize that I'm just not going to worry about it. Questions on any of these problems before I scroll? Because when I do, the writing's all going to go away. I can't get it back. All right, so we were on question 8 then. Question 8 says, find the area of an isosceles triangle with sides of 5, 5, and 8. Area of a triangle is 1/2 base times height. What's the base of this triangle? 8. What's the height of the triangle? Not 5, right? So we don't know the height. So what we need to do is find the height of this thing. We are going to do that by drawing in the height, which should be a straight up and down line there through the middle of this triangle. What happens to that 8 when we draw in that height?
Bisected.
It gets bisected, split equally into 2 4s there. And when we drop that height down, it drops straight down to hit at a right angle. So then we end up having what? 2 right triangles, and we can do the Pythagorean theorem to find that height. So we're going to do 4 squared plus height squared equals 5 squared. So 16 plus height squared is 25. Subtract that 16 gives 9 is our height squared, which means that our height must be 3. So then we can find our area. 1/2 base is 8, height is 3. And we get 12 with no units in the problem, so we don't need units in our answer. Okay, so that one we had a little intermediate step to be able to plug into the problem, remembering that we can use our Pythagorean theorem inside of a right triangle. So drop down to find height with a right triangle and use Pythagorean theorem. Questions on that? Okay, that type of problem would take us through lesson 2, and then in lesson 3 we're going to look at trapezoids. Trapezoids might be a little bit less familiar to you. We learned back in chapter 5 that a trapezoid has one set of parallel sides. Those parallel sides are called the bases. So in this problem we're told that they have lengths of 12 and 8, and we have a height of 7, and again height must be straight up and down. Our formula for a trapezoid is area is 1/2 of base 1 plus base 2 times height. It's kind of like a triangle, 1/2 base times height, but there's 2 bases. So we're going to add them together. Okay? 1/2 of base 1 plus base 2 times height. Or it's kind of like the idea of a rectangle, and we're taking the average of those bases times the height. A couple different ways to think about it. It does need to be memorized for the test this week, so this one might require a little bit more study to make sure you have this one memorized. So 1/2 base 1 plus base 2 times height. Doesn't matter which one we call base 1 and base 2, because when you add, 12 plus 8 is the same thing as 8 plus 12. And that's what we need to do first. Our order of operations says we need to add before you're allowed to multiply. So we'll add those up first. And then multiply this all together gives 70. There were no units in the question, so we don't need any units in our answer.
Wait, is that okay? Never mind.
So it says find the second base of a trapezoid, where the first base is 3, and the height is 3, and the area is 12. So area, our formula is 1/2 base 1 plus base 2 times height. So then 12, that area is 1/2 of 3 plus x times 3. Okay, base 1, 3, base 2, we don't know, and height 3. So we need to do a little bit of algebra on this one to solve it out. So how do I get rid of the 1/2?
Times both sides by 2.
And multiply both sides by 2. Multiplying by 2 cancels multiplying by 1/2. So then 2 times 12 is 24. And I'm going to distribute that 3. 9 plus 3x. We're going to subtract 9 from both sides of this. So 24 minus 9 is 15. Then we find that other base must be 5. Sorry, there's really very little room to do work on here. There's not a lot of space to do work. Questions on the process of solving that one? Okay, last one here. Find the area of an isosceles trapezoid. An isosceles trapezoid, we learned back in chapter 5, is a special trapezoid where the 2 slanty sides are the same length. Those slanty sides are called the legs, and this problem says that they're both 5. And our bases are 10 and 18. The bases are the parallel sides. area is 1/2 base 1 plus base 2 times height. We know base 1, we know base 2, but we do not know height because height has to be straight up and down. So our heights would be like those. So I'm going to draw both of those in. When I draw those in, that 10 that's up on the top could copy down and be that middle part of the bottom. Which means what about those other two parts? They're both 4 because I need 18 along the bottom of this thing. So if I'm taking up 10 in the middle, I've got 8 left over, and this whole thing is very symmetrical because of that word isosceles. If isosceles wasn't there, we wouldn't know this was true. But because of that word isosceles, it's going to break up equally to give 4s on both sides. So then if I need to find this height, I can do that once again with the Pythagorean theorem. 4 squared plus height squared is 5 squared. This actually turns out to be exactly the same Pythagorean theorem as we did in number 8. It's really exactly the same thing as up here. Over again, it turned out to be the same numbers. So that height turns out to be 3. So then our area is 1/2 10 plus 18 times 3. Order of operations, we need to do our adding first to make that 28. And then 1/2 times 28 times 3 is 42. Since there were no units in the problem, we don't need it in our answer. Questions?
Is that all due tomorrow?
So the homework is all 3 of these lessons. It looks like a lot because it's split out in different groups. It's 22 problems, so that's not really more than a normal assignment. Assignments are generally, depending on the types of problems, 10 to 30 problems. So this is 22, kind of right there in the middle of what a normal assignment is for us. It's just split over the 3 sections. So that being said, make sure you're looking at the right page for the right part of the assignment. Sometimes people get it started in class or in study hall and then you go home. Make sure you're looking at section 1 when you do section 1 problems, section 2 for section 2, etc.